Hello, everyone. Let me introduce you to Andrew Lelechenko. Andrew is a maintainer of many Haskell packages, such as bitstring and text. And he just finished the UTF-8 transition. Andrew also holds a PhD degree in mathematics for his contributions to the theory of the Riemann zeta function. And he also enjoys riding horses, bicycles, motorbikes, and reading Welsh manuscripts from the medieval times. And today, Andrew will talk to us about benchmarking with Tasty Benchmark.
Hello, everyone. My name is Andrew, and thanks for having me this morning. I'm gonna talk about a new library to facilitate benchmark of your packages and applications in Haskell. I mean, every time when a person presents a new framework for testing or for benchmarking, I often have this like provocative question: how dare you to suggest that I need to learn one more framework? Don't we have enough frameworks in Haskell ecosystem? Because like in various parts of Haskell package landscape, many people suggest that we already have too many alternatives and we need to focus efforts on working on existing ones and not inventing a new one. And in Haskell, we have like at least two major players in benchmark landscape, which are Criterion, which is very well old known, most popular framework for benchmarks, and we have Gauge, which is a bit, well, newer, but probably at least 5 or 6 years old, and which is also very much established. So I would like to start my talk with answering why I was not quite happy with existing solutions, why I didn't go and resolve my grievances by patching Criterion or Gauge. What exactly the new framework which I'm talking about, Tasty Bench, what exactly it brings to the table, what is, at least from my personal perspective, better with it, and what makes this new benchmarking framework valuable, especially for developers who work on Haskell core libraries. Like core libraries, it's fundamental Haskell libraries which are either dependent upon by GHC itself or very deeply ingrained in Haskell ecosystem, such as Vector, for example, or Random. I'd like to use this moment to explain my gratitude to existing benchmarking frameworks, to their authors and to their maintainers, and the fact that I'm not quite happy with all aspects of them is obviously my own issues, and it's not meant as a critique of maintainers of these excellent benchmarking frameworks as they are. But I'll probably start with explaining my difficulties with existing solutions from this piece of output from Criterion. And this is not something I invented for the sake of argument. Yeah, this is the very first example from Criterion tutorial. And in Criterion tutorial, we benchmark some simple implementation of Fibonacci numbers. We run this function fib on argument 1, and here is an output we receive from Criterion. And honestly, when I see this, and this is the default output, this is no options passed to Criterion. Honestly, when I see this, I'm very much overwhelmed. Like there are 13 numeric quantities here. Like I'm a developer, I'm asking, give me a benchmark for this particular function call. And I usually expect, like, we know these benchmarks for video games, for like measure performance of your CPU. I usually expect to receive one number, like benchmark. But here I see 13. And to be honest, relationships between them are not clear to me. Like if I just see this from get-go, like there are probably at least 6 numbers, yeah, which looks probably like a actual time from my application, from my which my function has taken. Yeah, but I have like this time row and I have this mean row, and actually it's quite confusing for a developer who is not deeply involved into this to answer what's the difference between time and mean here. Yeah, and actually what exactly is characterized by these bounds? Because most of the time, like people read this output like something like this, that mean, like people look at the first line and they think that this report means that the function runs in average in 23 nanoseconds, and most of the time its running time is between 23 and 24 and a half. But in fact, like if you really read the tutorial, like Criterion comes with a very good tutorial which actually does explain all these numbers. The problem is not in not having a tutorial. The problem is that it's just not the best default interface for a casual developer. And actually, these bounds, they do not say anything about how far away from the mean value your function can deviate. These are bounds for mean value itself. Like this is a statistical estimate saying that most of the time, like with high probability, your mean time is between these bounds. But actually your individual estimates can deviate potentially as much as it happens. And to estimate this, you need actually look at these two numbers, mean and standard deviation. And this fact that actually your function like behaves not between 23 and 24 and a half, but actually your function is running somewhere between 24 minus 2, 24 plus 2, it's not evident from this form of report at all. Then besides like confusing time and mean, I also have some R squared, and I also have some strange diagnostic message which says that my results are severely inflated. And what what I'm not quite happy here is that it says like, I don't know, is it good enough? Is this R squared enough? Or are my results just garbage and I need to rerun? Like, how bad is it that my variance is affected by outliers by 88%? Like, does it render my results ineligible? I don't know. Criterion doesn't say me. I mean, Criterion is a very powerful statistical framework. It allows you to answer questions like no other framework can help you to answer with. But basically, its default output doesn't give a developer enough guidance to understand. Like in this particular case, like situation is probably 50-50. In fact, because R squared is quite high enough. But like I always have shivers when I see this severely inflated, because basically it probably means that I need to rerun this benchmark. And in practice, you're likely to have like hundreds of these results, and half of them will be inflated, and some of them will be with bad R squared. And I don't really even understand like how, like, from my perspective, if results are bad, yeah, if outliers are too big or R square, whatever it means, we are casual developers, we don't even know what R square stands for. Yeah. And maybe just do not show me bad results, because no point to show results which I cannot act upon. And ideally, if like after several runs, my benchmark framework didn't come with statistically significant data, well, maybe it should rerun automatically until desired quality is achieved, right? So my point here is that reading benchmark report shouldn't require a PhD in statistics and probability. Like, ideally, results should be ready for consumption and should be actionable. Like, either you have good quality, then just give me numbers, or they are of bad quality, then just do not show numbers and continue running further. Another question about these outputs is probably a bit unexpected, but actually, what time are we talking about here? And it appears that by default, Criterion and Gauge, they report wall clock time. This is actually a reasonable thing to do in an ideal situation when you have a server at your disposal, when you have no background processes, when you are not affected by anything at all. In this case, measuring wall clock time is in a certain sense, it's the most meaningful answer to how long does my application take, because, well, it accounts for everything, it's wall clock. The problem with this approach is that, unfortunately, instead of running our benchmarks on dedicated servers, most of the time, like 99% of time, developers are running benchmarks on their personal laptops. And on your personal laptop, you have like a ton of other applications, at least your editor and Haskell language server, and a lot of stuff which comes up unexpectedly and decides that it's a time for it to do its very important job. You have like hundreds of system services. And most importantly, probably you are quite bored waiting for your benchmarks to finish, because it could take hours. And so probably while you're running your benchmark suite, you are watching YouTube, you are scrolling Facebook, and all this contributes to wall clock time, because wall clock time is all encompassing. Like, you can set up Criterion and Gauge to give you another measurement of time, because of these things, there are two possible solutions. Like, either all developers should exercise willpower and restraint and just sit stone when benchmarking. But honestly, in real world, I do not believe this happening. At least for a casual developer who is just like running benchmarks for some small patch to byte string or text. Or it would be better to measure like dedicated CPU time for your benchmarking process. And you can set up Criterion to give you CPU time, but it's not a default configuration, and it's a bit hidden beneath. And everything becomes probably even worse when we look at the real benchmarking test suites. Because in real world, like there are probably two situations when I run benchmarks. And my claim is that existing frameworks are not quite helpful with these two most common scenarios. And first scenario is basically I have several competing solutions. Like maybe I'm benchmarking several libraries which do the same thing, and I wish to know which one is faster. And maybe I have like several implementations for sort, like on this example, like merge sort and quick sort, and I would like to learn like how much faster is merge sort than quick sort. And if you run this in Criterion, you basically get this report, like it's a sheer wall of numbers. And honestly, there is no help to you to actually answer your question. Like we do not care about absolute numbers. Absolute numbers are different on every machine in this universe. Like what we actually care is what is the ratio of merge sort time to quick sort time. And it appears that our interface doesn't provide us with any means to come to an answer. Like I'm probably supposed to just copy paste these numbers to an Excel spreadsheet and to divide them myself. And on large scale, it's very much impractical. And another like very common use case for benchmarks is when we benchmark our whole benchmark suite against some patch. Like imagine you are an open source maintainer and you received a pull request, and you ask a contributor to run benchmarks. So you would like to know that nothing went worse after a proposed patch, and you ask a contributor to run benchmarks. For instance, most of the time I review pull requests from my mobile phone. I don't even have a possibility to run benchmarks myself. And well, a contributor just sends you a wall of numbers just for this particular run. And for like package like a text where like about 1,000 of individual items in a benchmark, it's just a huge, huge, huge text document. And you cannot act upon it. And then you ask a contributor to run benchmarks both before and after the patch. You should have done it from the very get-go, but well, you receive two walls of numbers. Again, there is no direct way to compare them. Like what you should have done, you should have asked actually to generate CSV reports, and you should have used some probably AWK or something like this to generate comparison between them. And there are several tools, actually third-party tools, which can compare reports from Criterion. But again, it's a very common scenario, and it's too much involved in this case. Like no one is giving me an easy interface here. And essentially, we are doing manual performance testing. We are manually comparing reference with new results. And we do not do so in correct in testing of our packages in general. Like we all aim for automatic testing, but somehow in the field of performance regressions, we still use this manual approach all the time, and it's very much counterproductive. I also often work with GHC head, and the reason is that if you support like core packages and you're interested in their performance, you must test against GHC head, because when GHC is already released, it's too late. Like most of performance issues were already introduced, and you will get them fixed only in some patch release, maybe, or maybe in the next major release. And historically, core packages used Gouge because it has few dependencies, but unfortunately, recently, even these few dependencies are not updated in time. And you can switch to Criterion. It has a lot of dependencies. It's kind of a giant of frameworks, but all these dependencies are well maintained. The problem is that if you build against GHC head, you basically have new GHC every day, and building all criterion dependencies takes ages. And another problem is that these dependencies have a huge chance to involve the package you are actually interested to benchmark if you are a core library maintainer. And in this case, you have a circular dependency and you need to use some special means to help with it. So looking at all this, like back in January this year, I was like, okay, probably I need to develop a new benchmark testing framework. And honestly, this very thought, like it caused me like, okay, I need to reinvent the wheel again and again, because like what a benchmark framework is doing, it supports a hierarchy of benchmarks, like you have individual items, you have groups, you have names for these groups and items. I mean, it's not difficult to support, but someone has to write the code. Yeah, you need to manage resources, like if you are like benchmarking some IO actions, and you need to be careful with freeing them, and you need to handle exceptions gracefully. And honestly, I hate handling exceptions in Haskell. And you need to generate some console output, which is again not a rocket science, but it's some craft and it needs to be written. And there are some common facilities, like you need a way to list all available benchmarks, you need a way to filter benchmarks by their name and stuff. And I was looking at all of this and I thought that no way, I'm not going to write it. Like it's too much of boilerplate and I really have other things to do. But then suddenly I realized that we already have such frameworks. And yeah, you also need to provide command line interface, and you need a way to provide more command line options and whatever. And after pondering about all of this, I understood that actually we have very mature testing frameworks in Haskell. And basically, testing frameworks are doing all of this. Like if you replace word benchmark with test, yeah, you just get a description of a testing framework. And we have very good ones in Haskell, like Tasty and HSpec and a couple others. So I got an idea that maybe instead of writing a new benchmark framework to help me with my needs, I can write just a plugin, just an ingredient for Tasty in my case, which will do all work which is specific for benchmarking, and let Tasty handle all these things without my input at all. And it really worked pretty well. Like it appeared that you really can implement benchmarking framework as a plugin for Tasty. Benchmark is literally a type synonym for test tree. And there is a test provider which basically converts benchmarks to Tasty tests. Resources and exceptions are all managed completely by Tasty by native means, and you basically have a usual Tasty interface if you ever used it. Console output just hooks into a native Tasty console test reporter. You can implement CSV and SVG reports just as Tasty ingredients. It's kind of plugins. Command line interface, listing and filtering of your benchmarks, all native Tasty functionality. You don't need to write a single line of code at all here. So Tasty Bench is actually not a framework at all. It's just a plugin for Tasty. But it appears that in this case, when all this boilerplate is taken away from us, we can just concentrate on providing a great benchmarking experience without worrying about all of this stuff. And the result is that Tasty Bench on on level of your code, yeah, API is compatible with Criterion and Gauge. Like basically looking at this page of code, yeah, this is a standard benchmark for Fibonacci numbers. It could have been Criterion, it could have been Gauge, and the only thing which shows that it's Tasty Bench is this import. If I replace this import with import Criterion or import Gauge, it's still a valid benchmark which is measuring the very same thing. So basically, despite being a plugin to some tasting framework, we can maintain the very same API as previous solutions. And the default mode of operation in Tasty Bench is, first of all, measuring CPU time, specifically CPU time of your process and not wall clock time, which gives us a bit more independence from other system processes. And Tasty Bench is goal-based. So you specify precision you are aiming for, and Tasty Bench will rerun tests, will rerun benchmarks until this precision is achieved. By default, it uses precision of 10%. And so in this output, you can see that for all results, like this plus minus part is within 10% of mean time. And this is an example of output. So far, there are less numbers than in Criterion, and the goal-based approach helps us to receive only results which are meaningful. So there is also a CSV reporter, which basically dumps the very same data in CSV. But the trick is that in Tasty Bench, we do not only write CSVs, but we also can read CSV files from previous runs. So you can prepare baseline CSV with their CSV key. You can apply a patch to your library, and then you can remeasure. You can rerun against baseline with specifying your baseline with their baseline key. And basically you receive this kind of report. Like it immediately says you that this one is slower than baseline and this one is faster than baseline. You do not need to run any third-party tools. You do not need to wait until your benchmark is finished and done. You receive these numbers as you go, and it's very helpful to have this kind of interaction with your benchmark. Like maybe you just saw the first result and you already know that it's not good enough and probably you need just stop, abandon your patch. And this is very helpful when your benchmark suite is like thousands of items. And you get this like immediately, nothing, no setup, no things to care about. What is probably more interesting is that by virtue of being actually a testing framework, we can not only report that something is slower and something is faster, we can actually convert this stuff to tests, like real regression test suite, which will fail and show me a red signal that this is not good. Like you can pass arguments, yeah, which will mark down like all slow downs as failures, or there is a key to mark all speed ups as failures, because sometimes unexpected speed up is also an issue which you would like to investigate and take a closer look. And you can use like native Tasty key hide successes to focus on problematic benchmarks only. So in our like previous example, yeah, we have 3 benchmarks and one of them was slower, second was mostly the same, and the third one was faster. So if we rerun it with fail if slower, fail if faster, and hide successes, we just receive this kind of output. Like it focuses our attention on benchmarks which have changed. And you can be pretty flexible. Like you can, if you use only fail if slower, you'll see only this one. Because if you don't care if something got faster, yeah, you can just get problematic pieces of your test suite. And another consequence of being actually tests and not benchmarks is that you can intersperse your benchmarks with unit tests, property tests, and stuff. Because very often, like when I benchmark something, I am changing the implementation of my function. Yeah, and there is a huge possibility that I have introduced a bug there, aiming for better performance. But currently, you need to run test suite separately and benchmark separately, which is not always quite convenient. But with TastyBench, you really can have just one executable doing both things, and you can just basically run correctness tests first, and then you run your performance tests, and you receive all output unified in one go. This is very helpful when you are changing your implementation to achieve better performance. You can check performance and correctness at the same time. And as I said, there are like two main use cases for benchmarks. One is comparing your package before and after a patch. And another one, when you wish to decide between several competing implementations and you wish to learn which one is faster. And TastyBench provides a facility for comparison between individual items. Basically, here we say like, here is like benchmark FIBO for 5, and please compare it with performance of FIBO 10. Yeah, and here we also say like benchmark FIBO for 12, and please compare its performance with FIBO on 10. And if you run this benchmark, you'll receive a result like this, like here is your baseline, here is your basically unit of measurement. Yeah, and this one is like 12 times faster than your unit of measurement, and this one is 128 times slower. So basically, you can have like several competing libraries here, and you immediately get answer to your question, because your question is not an absolute performance. You never care about absolute numbers here. Like every time you care only about relative numbers. Either it's relative to your previous commit, previous state of your package, or you care about relative numbers between individual items in your benchmark suite. And basically, TastyBench gives you a handy way to compute this. Coming soon to TastyBench are actually portable regression tests, which do not depend on baselines. I mean, in the sense that instead of generating a baseline first and comparing with it, like it's a stateful computation in essence, like you need a place to store your baseline somewhere. Yeah, what you can do instead, you can actually use this facility of comparing competing implementations. You can compare the performance of an interesting function to the performance of some non-interesting function, like which is just counting lengths of a long list or something, which just gives you an idea about performance of a CPU. And then you can put bounds on these numbers. Like in future, it will be possible to say that please fail these tests if it's like slower than 200 times than this one, or please fail these tests if it appeared to be slower only 10 times than another one. This is what gives you a portable regression tests for performance. Yeah, and speaking of core libraries like TastyBench, since TastyBench is just a plugin for Tasty, and Tasty has a low number of dependencies, you can immerse benchmarks as a part of the main package. Because historically, benchmarks in core libraries are very often a separate package from the main one. That's because of circular dependencies, because Criterion has huge chances to depend on your core library. So you need to separate these packages. And it has various difficulties, like you need a Cabal project from get-go. You do not publish your benchmarks on Hackage when you publish your package because they're separate packages. And there are some inconveniences with rebuilding all the stuff all the way down, because if you changed your main package, you'll likely need to rebuild not only benchmarks, but you actually need to rebuild Criterion itself. And it takes a lot of time. And with TastyBench, we can just immerse benchmarks into the main package. It's published on Hackage. It doesn't need any setup at all. It means that we have simpler CI setup. And by virtue of having less dependencies, we use less CI cache, which is quite important. Like you get faster CI builds. It means that you have better contributors experience, because the casual contributor doesn't need to delve into the structure of your project to understand like how many packages are there and how to run benchmarks. Actually, it's all just Cabal bench. Yeah. So it means that maintainers feel themselves better because they do not need to explain to everyone how to run benchmarks, and they have these means to compare between runs and answer quickly a question whether a proposed patch is good or not. Yeah, so provide answers for important questions faster. And again, because there are low dependencies, TastyBench is happy to handle bleeding edge GHCs, and like maintainers of core libraries, they often need to like rebuild many times with various configurations and stuff. And having a lightweight framework is incredibly helpful for this. So current status is that TastyBench, with all its features, it's only below 700 lines of code. It includes console, it includes CSV reporter, and even an SVG reporter, so you can get nice pictures from TastyBench as well. We have built-in comparison between individual items and between runs. No dependencies at all, except those which are implied by Tasty. So if you use Tasty as your testing framework as well, you need to build only these 700 of lines, and that's it, and no additional dependencies. That's why TastyBench builds up to a magnitude faster than Criterion and Gauge. A wide range of GHC support, basically all GHCs starting from 7.0 and to head as of today. API is compatible with existing frameworks, so there is no headache to switch. We have a couple of early adopters of TastyBench, like byte string, text, primitive, vector, random, pandoc, for example. So it's more or less tested in the real world. And as a maintainer of byte string and text, I'm very happy to have this tool. It made my life much, much, much better. And speaking of recent events, I would never really manage to switch text to UTF-8 without TastyBench, because it improves benchmarking experience a lot. Bottom line is that TastyBench is not about fragmentation of benchmarks. It's actually about unifying testing landscape, bringing performance testing back home to testing. So benchmarks are no longer separate things from tests, actually. So it's about unifying both technically, because it's just a plugin for Tasty, and ideologically, yeah, because we make performance regression testing more accessible than it was before. And that's it for today. Thank you very much for attention.
Okay, thank you, Andrew. We do have a few questions. And the first question is from Seb, which would like to know when you mix tests and benchmarks, can you still run the tests without the benchmarks?
Yes, you can. I mean, in Tasty and consequently in Tasty Bench, you can filter by names. So if they have different names, you can run them separately.
Okay. And we have another question from Joachim. And the question is, when comparing items, do you just compare the means? Or is that a statistically fancy result that takes variance into account?
So the answer is that usually in a comparison between items, we compare means, but if the difference between results is less than variance, we just do not show results. Like in this situation, like this middle benchmark, it doesn't necessarily need to be exactly the same time. Like in this case, it's just that the difference between its new mean time and old mean time is less than variance. And so Tasty Bench decides that the difference is not significant and it doesn't say that it's slower or faster. But for like two other tests in this run, it appears that the difference here and here is statistically more significant, more than double standard deviation. And Tasty Bench decides to actually say that I think this is significantly faster and not just an outlier. So we take deviation into account when we report these results to understand whether it's significant or not.
Okay. We have another question, which is, how easy would it be to use the library without Tasty?
There is a low-level interface, which basically gives you a function, just gives you a function measure. And so basically these NF, like normal form NF fever 5, these things, they produce benchmarkable. And we expose a function which just takes a benchmarkable object and gives you a time, returns you time and standard deviation. So you can use it without Tasty at all. If you wish to like do some your own kind of analysis, you can.
Okay, thank you very much. I believe these are all the questions that were asked. Maybe there are more questions that can be asked on spatial chat.
All right, thank you very much, and see you in special chat.